Okay, welcome back. In this video, I will show you how you can create installable Python packages from your project. So we are kind of making the last step in our development. Now we developed our project and now we would like to package it up and distribute it so that other people can also use it. If you want to follow this exercise, you will need some prerequisites, and actually we will need the build tool for Python. So you would have to install via Conda. If you are using the Conda environment, as we do in this course, you should make sure that you are installing the build tool in your Conda environment. Okay. Now, if you think about distributing Python projects, right, and basically there are two different scenarios and two different target audiences which you could address. First of all, you could address the developers, so people who want to basically help you to develop your project and would like to contribute to your project. And basically those people need all the information about your project you can get. That means they need all the files in your project, of course, all the source code in your project. They would have to access all the tests in your project. They would have to have access to all the development related files like .gitignore or some other files which are important for the development. And they might also need the development history itself if they want to look up something back in the past or fix something which was broken already in the past. Of course, the best way of participating in it, as we have seen in the previous videos, is to distribute the Git repository, so to give them your Git repository because it contains basically all this information. And of course, you can send them the Git repository, or you can use some publicly hosted Git repositories, as we have discussed: GitHub, GitLab, Bitbucket, whatever is available. The other main target audience for your project would be the consumers and the users who basically are not really interested in the details of your project. They just want to use its exported functionality. Like if you think about that, when you're using NumPy, you don't really, mostly you are not interested in the internal details of NumPy. You just want to make sure that if you use the array function, it creates an array for you as it is supposed. No, then for them, the Git repository would be an overkill. And for them, it's much better if you have an installable package. In the Python world, often this is called wheels, or there is one format which is called wheel, which we use in this video. And basically, you would just distribute those wheel packages to the users and make sure that this wheel package only contains information which is essential in order to use your project, but it doesn't have to include any other meta information. You can give these wheel packages to the users just by uploading to some website, or you can use publicly hosted package repositories. And there are two such package repositories in the Python world which I use. The first, the PyPy, which is basically the standard Python packaging repository, the package repository. And actually the package management, the pip tool, the command line tool pip is even part of Python. And in this video, I will show you how to handle this pip tool and how to install packages via the pip under Python. The other one, which we already know, of course, is Conda. Conda is much more complex, and therefore I will not discuss in this video. It's used not just only for Python packaging, but also for other software, compiled softwares, and so on. So basically, it enables much more complex scenarios, but it's also much more complicated or much more complex to set it up. And of course, if you want to use the Conda package management tool, then this is something you must be installed additionally first, because it's not part of the official Python distribution. But that you did that already for this course, so you know about that. So in this course, we will just have a look on the PyPy and how to use pip as a package manager. Before we do that, I would like to discuss the concept of virtual environments in Python. So basically, just think about that. If you want to give the user a package and you want to the user to install your package, you must make sure that you can test your package under conditions which the user have. But of course, in your Python installation, like in Conda, you might have installed several packages already, and maybe the users do not have those packages. And therefore, it would be very important to be able to create a clean Python distribution, which is completely independent, which does not contain the third-party modules which you installed already, but has the minimal Python installation, which usually comes with the Python distribution if people only install Python. And this is exactly what virtual environments allow you to do. So basically, you can create separate Python environments, each of them separated from each other, and each of those environments you can install packages independently. Of course, if you say, okay, wait, this is the same as the Conda environment, then it's not a surprise. Conda works exactly the same way, and actually Conda is a more complex setup which bases also on Python virtual environments. So how can you create virtual environments in Python? And probably this is something I will show you basically on the command line. So if you have just a folder, I am now in the SciPro folder, and I would like to create a virtual environment, then I'm just importing the venv module in Python, and let's call our virtual environment just myenv, right? So basically I'm importing the VM and I'm giving the name of the virtual environment I would like to create. It's very important to note that here I already loaded our Conda environment, and this virtual environment which I created now, which is actually, if you have a look at that, is just a directory which had been created. This will be associated with the Python version which is in this Conda environment. However, it will be a Python version, a Python distribution which is free from third-party modules. How can we check that? Let's have a quick look. First, I'm just in the SciPro environment where I am now. I'm just starting Python, and I am just importing the NumPy module. And it works quite nicely because in Conda, in the SciPro environment, we already installed NumPy. Now, if I'm activating my virtual environment, which I called myenv, this I can do very similar how I activate Conda environments by just sourcing within the myenv folder, the bin folder, the activate script. Then you see that now within SciPro I have another environment, myenv, which is active, right? So this is a virtual environment which is associated with SciPro, but it's a clean Python installation. Now, if I'm trying to start Python, and now I'm trying to import NumPy, it doesn't work anymore because now I'm seeing this clean new Python environment. If I do not want to have this environment anymore, I can just deactivate it by using the command deactivate, and then I'm out of myenv and it's not active anymore. And if I do not need this virtual environment anymore, I can just simply delete the directory, and that's it. Okay, but how can I, no, we have seen that NumPy is missing. How can I add further packages to this clean environment? So let's just create it again, right? And let's just source it or activate it again. Here, I'm just activating it, and via the pip tool, I can install packages from the PyPy repository. And for example, the PyPy repository, of course, contains NumPy as a module. And if I say pip install NumPy, it will install NumPy into the myenv virtual environment. It's very important that you should never use pip to install things into a Conda environment, but you should use pip in order to install things, Python packages, into virtual environments which you created, and now it had been created. You can also install package files which are local, so not necessarily on PyPy, but you, for example, package files which you generated, and I have generated a package file in the downloads folder. There is a lin solver, or it should be, wait a second, let's have a look. Downloads. Yeah, there's a lin solver wheel, which is a package file, and now I'm just installing it with pip install into my virtual environment. And instead of giving the name of the package, I'm just specifying the name, the path to the package file, the so-called wheel file. The wheel package format is an installable Python package format, which we will see in a second how to generate. But if I'm just creating it, then it installs into the myenv virtual environment. How do I know that it's there? For example, we will see how, but I created a standalone script, lin solver, in this project, and now I can call this lin solver standalone script with for example, with a -h option, or if I'm starting Python 3, myenv is active, I could even import the lin solver package without any problem. Okay, so this is basically how I can install packages. And now the question, how can I create such installation package files, such real files. In order to do so, let's have a look at the slides again, and I will just go to the position where I already here summarize for you. First of all, it's very important that your project, also if you do not install it, but especially if you want to install it, it should have a certain standard layout. And the suggested standard layout, the so-called flat layout, which I'm showing you here, looks basically the following. You should have, of course, a README file in your project folder, which tells the essential information about your project. You can use an RST file if you like RST, like me, or Markdown is another very common format which people use for README files. You should have a license file which tells you what kind of license your project has. My project here, my sample project, will have an MIT license. Choosing the license is a special issue. Just read about it a little bit and decide on a common license. If you do not know what to take just MIT. Then you need a package description file, pyproject.toml, which tells the Python packaging system a lot of information, necessary information about your project. We will have a look at that later. Then, as we discussed in the previous video, it's very important to create a package for your project, so that your modules are within a package. The name of the package, which is just should be, of course, the name of your project. So that means you have to create a folder with the name of your project. In this case, it's a linsolver, and this linsolver should have basically our Python source codes and, of course, the init.py function in order to signalize that this is a Python package. And the standalone program which I was executing before, this is also a Python program with a special function in it. We will have a look at that later as well. And this linsolver.py I'm also putting into the linsolver, into the package folder. So this is the standalone program where I created a main function which is which, if it's called, basically executes the script. Okay, a part of the package folder, of course, you should have a folder for tests, which is by definition usually called test or tests, and the docs folder for the Sphinx documentation. The layout which I'm showing here is a so-called flat layout for installable package, and there's also an alternative layout which is called the SRC layout, where you have an SRC folder and your project package folder is within the SRC folder. I'm not explaining it because it needs a little bit more tweaks for beginners. However, it's a little bit more robust layout. So if you are really serious about packaging and Python project management, you should just look up these links which compares the two layouts and tells the pros and cons. And you should consider maybe to use the SRC layout, but however, that needs a few more tweaks for external routines like pylint and pytest sometimes, and therefore I'm not dealing with that here in this video. Okay, now let's have a look at the project description file, this pyproject.toml, and basically this is something which tells the build system the essential information about your project. First of all, it selects the build system itself, and there are different build systems in Python. I'm not even going into any details about that. If you know them, use the one which you like here. If you don't know any of them, then use just hatchling here. So basically just copy and paste those 3 lines into your pyproject.toml file. Then there is a section which gives the meta information about your project. There are several fields here. Many of them I didn't even show, but the minimal configuration would be roughly that what is staying here. And it's very important just to specify the name of your project. You can give it a version number. It's very important to tell the people which Python version you require in order to be able to run your project. You should use the Python version, the oldest Python version, which is possible, which can be used to run your project. Here we were using some hinting construct which were new in Python, so here we are specifying version 3.12 or above. Very, very important that you are declaring dependencies. Our project needs the NumPy module, and as you have seen in the virtual environment, NumPy was not present. And in order to make sure that pip can automatically download NumPy when our project is installed, we are specifying NumPy as a dependency. So if you have any other external dependencies, you should list them here. And then there are some meta information about maintainers, descriptions, which file is the README file, which file is the license file. And then there is one more section here, project.scripts. And this is about the standalone, how the standalone program, command line program, linsolver can be created. This I can show you on the next slide. So basically here, again, the section is called project.script. And I'm telling in this declaration Python that if my package is installed, then please create a command line tool called linsolver. And if somebody calls this command line tool linsolver, then please import the module linsolver.linsolver. So basically the linsolver module within the linsolver package. And when you import in this module, please execute the function called main from within that module, right? So this is basically what this declaration does. What does it mean? It means that basically if somebody types linsolver, as I did before, then basically it will automatically run and execute this main function. Actually, it is one could do it also by hand without this declaration. It's equivalent if somebody would have imported the module and executed the main function from this module. But of course, it's super complicated to type so much, and it's much nicer to have one executable, one short command name in order to do that. So basically, this is everything we need. And now what we want to do, we want to build basically a wheel file, an installable package file from our project. So let's change back to the command line. So I am here in my project folder. My project folder is called linsolver. I'm in the branch packaging, but it's not that important. Important is that I would like to create a wheel, a Python wheel, and that I do by importing the build module we have installed in Conda, the build module, the build tool. And in order just to create only a wheel and no other distribution formats, I'm just also specifying the -w option. If I execute it, then apparently it doesn't work. Why doesn't it work? Because the environment myenv is still active, right? And here I didn't install the tool yet. So first I have to deactivate here the myenv environment. Now I am back in my Conda environment with all the tools which I have installed here. And actually I will also even delete away the myenv folder, because this virtual environment we will not need anymore. Okay, so let's go back to the linsolver project module. And now I'm just doing the same command again. So basically here I am just executing Python 3, importing the module with -m, the build module, and with -w, I'm basically instructing Python only to create the wheel file. And as you see, Python itself will create an isolated environment, and with this isolated environment, it will get the dependencies and create the wheel. Okay, and important thing is Python says we have successfully built a wheel with that name here. And this wheel is, if you list here in this folder the directories, there's a new directory which has been created, which is a dist directory. So I have a distribution directory. And if I list a distribution directory, indeed, there is a wheel here. And now we would like to test whether this wheel works as supposed. So we will install it. In order to install it, we will definitely not install it into the Conda environment, especially not using pip. But again, as we learned before, we will create a new virtual environment. So let's do that. I'm going out of from the project folder. I'm just importing the virtual env module, and let's call the virtual environment which we will create linsolver.venv, right? So if the linsolver.venv environment had been created, that means there is no a directory which is called linsolver.venv. Then we are activating this virtual environment by sourcing the bin activate script within this folder. Now the linsolver.venv environment is activated, so now whatever I install now via pip, it will go into this virtual environment. So let's install our freshly created wheel into this directory. So we are saying pip install, and then we will just take from the linsolver project. This was our project where we created the wheel from the dist. Folder, we will take the linsolver. But let's first just list it so that we can take the path, because otherwise my shell is looking for Python packages on PyPy. So basically I will just ls linsolver pip/dist and then this file, and now instead of ls I will say pip install and just this file is this long name. So from the linsolver folder, from the dist, which we let's take the wheel which we just built before and install it into the freshly created clean linsolver virtual environment. Okay, I am installing it, and then you see you can already see that what it does. It knows that numpy is a dependency. Therefore, pip also installs numpy into this virtual environment, and additionally, it installs also our project. How do we know that our project has been installed? For example, if I'm doing linsolver -h as before, it can now be executed because I installed my linsolver program here. Also, if I'm just starting Python 3, I could again import the linsolver module, because it had been installed into this virtual environment. So this way you can basically test your project. You can install files into the virtual environments and packages. And actually this should be always the way, if you are not using Conda, this should be the way how to install Python packages in general. So if you want to test a Python package or you get from somebody a Python package, the first thing you do, you create a virtual environment, a clean Python installation, and then into that you install with pip all the tools or the package you want, and the package should get all the dependencies automatically because they have been specified in the pyproject.toml file. Okay. The only problem with that approach is it's very, very fine if you are just a user of a package, but it's not very practical if you're a developer of the package, because think about that. Whenever you make any changes in your project, you would have to reinstall it again and again and again to make sure that also if somebody installs your project, your change project, the changes are basically affecting it as required. And in order to circumvent that, we can make a so-called editable installation. And this is, as I said, it's only practical for developers during developing the project. So how does it work? So first, let's deactivate my linsolver.vm environment, and I will just even delete it away. We don't need it anymore. And let's create a new one. I will just call it Python. I'm installing the VM module again, and I'm calling it linsolver. Let's call it devtest.vm, right? So basically, this is the testing environment during the development. So I'm just creating this new environment, new virtual environment. I'm sourcing it as always. So I'm just sourcing linsolver devtest being activate. And then now this linsolver devtest is the active virtual environment. Again, it's a clean installation, there is nothing. And again, I'm installing my project. However, no, I'm not installing the wheel, but I'm not saying I would like to make an editable install to my project. So I'm using the -e flag. And then instead of specifying wheel, I'm just specifying the project folder, the linsolver project folder. So this is the main folder of my project. And I'm just installing it. And then you see that it basically is not using a wheel, but it's using the project folder as a source, and it will install the project, but it will not be a hard installation in the sense of copying the file over, but basically it just creates so-called links which are showing to the files in the development folder. So what does it mean? So let's have a look. If I do, let's say, linsolver -h, then it's working again, and it says it solves a linear system of equation. And this is because I am in the virtual environment here. It's really coming from my clean virtual environment. No, I'm a developer, decide, no, this message is not that nice, I want to fix it. So I'm just going into the linsolver in my project folder. I'm just starting my editor there. Right, I will just start here Visual Studio Code in this folder, and I will just load the linsolver.py program, the script, which is basically the executable script. If you remember in the pyproject.toml, I can just show you just to remember you. If we load pyproject.toml, then you see that we were creating here in the last two lines here, exactly in those two lines, we were saying if you install the project, make a linsolver executable, which uses from the linsolver.linsolver module, the main function. If you look at the linsolver, linsolver.py program within the linsolver folder, you see that indeed it has a main function which does exactly what we learned. It will parse the command, create a command line parser, parse the arguments, and so on and so on. So this is my main program. This main function is the driver from the main script using the functionality from the other modules, right? Okay, and now here I will just change the description of the script, which I get as a help information if I'm typing linsolver -h, and instead of a, I will just write the. Okay, and now usually I would have to reinstall my project in a clean environment to check whether the changes are really affecting the installed project as supposed, but this is not needed here. I have an editable install. I'm still getting linsolver, the linsolver standalone from the dev test virtual environment. However, because it was not a hard install, but basically it was associated with my working folder, if I am typing linsolver -h now, you see that it immediately applies, right? So all the changes you do in your project folder, they immediately apply to the installed one. This editable install you should only use if you are developing, so during development. If you are installing an external package or a build you get from somebody, then you should use the normal install, but during development it's a very, very nice way to check immediately the effects of the changes of your project on an installed version of it. Okay, and with that you basically are already you have all the information in order to make packages from your distributable packages from your project. Of course, packaging and distributing Python, it's a very complex, basically a very complex topic, and I just scratched the surface here. If you want to know further details, especially if you want to know how to distribute your projects on the publicly hosted PyPy via the publicly hosted PyPy package repository, just open this link. This is a very, very nice description of how you should make Python packages and how you can distribute them using the pip technology. If you happen to want to write Conda packages actually on CondaForge, basically to be able to also to support users who are using Conda and not pip, then you can click on this link, because this gives you the first introduction of Conda itself, describing how to write a package from scratch. However, if you want to really into building Conda packages, I would suggest, because it's a little bit a complex material, I would just take an existing CondaForge project as an example, have a look at that, how other people did that, and with that in mind, read documentation and try to set up your package. And with that, I hope you learned enough that you can start with your open source Python project. You can basically have learned all the clean coding, all the necessary coding strategies and project layout strategies which are needed to have a successful project. You have learned about Git, again, which can help you to collaborate with others, and know also about packaging, which can help you to distribute your project. And yeah, have fun with your next Python project.